This particular session, the recorded version will obviously be shared with everyone for your reference. What you are going to talk about today is on Scratch. Uh, what Scratch is exactly? When we talk about programming, right? It's essentially an act of communicating to the computer. That's basically what programming is. We need to describe certain operations to computer so that computer can carry it out and we get the results that we want. And then there are obviously various ways of writing the code. Computer understands only binary, but binary is very difficult to us humans. So we try and give meaning to some of the binary characters, and that's where we get assembly, C, and other type of programming languages. The issue is, and I think probably anybody who has actually tried to learn programming and also to teach programming to somebody else is it's often very difficult. And what makes it difficult is no matter what we do, even the best C or Java program is not really readable to humans. So as the program, maybe just saying println to something on screen appears to be simple, but as the program gets bigger, people struggle to understand it. The struggle is universal, it's for everyone. It takes a lot of practice to get hang of it, and that's what drives most of the people. It ends up becoming just like mathematics. So what Scratch does? Scratch allows anyone to get introduced to programming through games. And by games, I mean basically what you do is you start. It is as if you are building various shapes using Lego blocks. So your programming is done by assembling different blocks together. Each block is an operation, as we will see sometime later. And using those blocks, you can do something very interesting. Uh, but uh, but there is also what I will try and address first is a myth that Scratch is basically only for kids. That is absolutely not true. Personally, while teaching programming even to university students, I have used Scratch to get them to understand programming first, because students actually complain that they find Android development and everything, basically any higher end development, difficult, because they first of all need to think about a lot of other environments, and on top of that they were struggling to actually imagine how to think like a programmer. So that's where Scratch has been useful. So let's take a look at some advanced things that's been done on Scratch. So I'll actually share this URL for anyone who's interested. Take a look at this. Like, somebody has actually developed Super Mario on this. It also has sound. I hope everybody knows what a game of Super Mario is, but I can play it here. So there you go. Oops, my bad. So yep, it also starts again, uh, and I can probably need to wait for, yeah, there you go. So it's just like the real Super Mario, and you can have a good time playing it. But the best part is, if you want to understand how this has been developed, all you need to do is click here, see inside, and you get to see the entire source code of it. So let's just click there and let's go and see inside. This might look complicated at start, but essentially if you see, it's entirely drag and drop of various blocks, just like Lego blocks, piecing together. We'll go about it in detail, but let's go and see probably some other example. This is a Flappy Bird game. It's quite popular game. It's, I'm not very good at that. So this is something which I did, but before we go here, it's basically to demonstrate a scientific concept of how the orbits work. So if you see that it actually draws or animates the Earth orbiting around the Sun and Moon orbiting around the planet. I actually didn't, while I was working on it, I didn't get a exact image of the Moon, so I just use a ball. From the far it looks like a moon to some extent. But what's interesting over here is two things. One is, if you see, and this was actually done with some school kids of 7 to 8 standard. I had actually shown this program to those kids, and they were able to do it themselves as well. What is interesting over here is while doing this, kids actually got introduced to concept of trigonometry. You cannot do this without using the concepts of trigonometry. So as you can see over here, and what makes it very interesting is probably if I go here for the basketball, and maybe if I put things like pen up and pen down over here, things get really interesting. So as you can see, it now starts drawing a shape, and I can draw various types of shapes just by controlling the speed at which Earth rotates around the sun and moon orbits the Earth, and you can basically get various type of shapes with it. This is basically introduction of two things of how trigonometry is important for us, and also how math is inherent in art. Multiple such examples could be given. I'll basically come to this example slightly later. It is essentially what I was trying to do was it first draws a road, but this takes time. Maybe I'll keep it running and we can come back to it and come back to it later in a while and see what it's trying to do. It is first trying to draw a road, a patch of the road, then it will try to draw a proper tar road on it. It will also draw the divider on it, and it will also move the bus on the road. And if you see what it is trying to do, it is nothing but a trigonometric functions used to implement certain interesting animations. I'll keep it running. Let's go to the next. I don't think this is something that I used. Maybe it was unintentional. Just take a look at what exists over here. So let me just press space, and this is a very simple example, but it draws a very beautiful image. So it just draws squares and then tries to rotate the square as you go along, and eventually you get a very beautiful pattern out there. So if you see, this basically starts getting kids interested into it. It's just square. So if you see, it's just pointing in a certain direction, moving in that direction, then pointing at 90 degrees, rotating at 90 degrees, and drawing this whole thing again. That's all it tries to do. Similarly, there is, so this was something interesting. It's slightly it's based on slightly advanced concept, but maybe I can try and show it to you. So what this does is simulates collisions. And when the two objects collide in an ideal world, that is, without friction being there, and if mass of one object is bigger than the other object by power of 100, then you actually get digits of pi. So take a look at this. If I do 100, then I'll actually get 1, which is the first digit, and 1. See, take a look at that. When everything stops, there are 31 collisions. Similarly, if I go next and run this again and make it, let's say, 10,000, I'll get 314. And this happens only if the difference between the mass of two objects is on power of 100. And every power actually talks about how many digits you will get over here. So when this is going to stop, you will actually get 314 over here. Just wait and watch. Two, 3, and it will do 4, and it will stop. There is nothing that I have coded over here to actually make this equal to the digits of pi, but it just so happens. It's a simple equation to derive how the forces gets exchanged when collision occurs. That's it. If you see 314, 2 digits, because 10,000 is 100 to the power 2. Yep. So that's really important, because you explain science and various other concepts of arts and mathematics through programming. Given that, how do we program with Scratch? what we simply do is go to scratch.mit.edu. You can actually create an account over there, and then you go and click on create, and it gives you an editor. So let's wait for it to load. So there you go. So if you, oops, it's refreshing again. Yeah. So on left, you have all the available blocks with you. If you see, everything related to motion. This is a sprite, I'll come to that shortly. But you have everything related to motion which helps you to control a sprite. Then you have everything, all the commands available to control the looks of the sprite. You have all the commands which are available in form of blocks to control a sound we want to make. Then there are events. Events is when, like for example, if you click over here, it will generate an event that says this is clicked, and you can actually start the program from that point. And similarly, you can use various key combinations on the keyboard to get detected as well. And these are all the events that are possible. Going forward, you have all the controls. This is pretty much known. There are loops, there are conditionals, there are delays, etc. There are sensors. So this is something quite interesting. You can actually sense if mouse is touching the object, or if in the camera you are touching a particular object, if your hand is touching a particular object, for example. All of that could be actually sensed over here. Operators, we all understand, mathematical operators, random operators, comparative operators, and logical operators, etc. So variables, we all understand what a variable is. It's a field that can hold any value assigned to it, and that value could be referenced just by the name of the variable. And blocks are like functions. We can create custom blocks, for example. Let's try something. What if I want this cat to move towards right? What do I need? I can say move 10 steps, for example. And every time I click on this, it will move by 10 steps. How do I make it move consistently in one direction? I go to control and I just say repeat maybe 10 times. I just drag it over here, and that's it. I click on that, the cat moves 10 times. How do I make it move forward continuously? Instead of repeat block, I'll use forever, and it will keep moving forever. There you go. So that's essentially how it works. It's still running. So even if I get that cat behind, it will keep moving ahead. So let me stop it. But this is about moving, right? Let's do something that gives us control. So we want it to move by 10 steps, but we want it to view, or basically point in a different direction when we press a key based on left and right. So let's try doing something like that, and then we'll put this in control. So how we go about doing that is, again, motion. So since this is related to motion, and you see that it has an option of pointing in a direction. So if this is pointing at 90 degrees, let me click on that, and if I click on this, it goes in this direction, right? That's essentially the idea, because if you see, this is called as a 90 degree because the 0 is over here. The top is 0 in the coordinate system. So you start from top and this becomes 90. If you get this down and make it 180, it will actually point downwards, if you see. And then if I run this, it goes down, right? There you go. So let me stop this. Similarly, if I want it to go behind, I say minus 90. There you go. And then it will go in the other direction, as simple as that. So using this, we can actually make it rotate. So all I can do is I can use the keys to either force it to go towards left or force it to go towards right. Let's try doing that. Let's use some events happening to start with. Let's say when this particular object is clicked, we want it to continuously move forward. At the same time, we want this blocks also to get activated. So let's also move that here. But we want to have an option. So let's point in maybe slightly lower direction like this, 105. When I'm saying this should happen only when I click the right button. So let's go there, and let's say in sensing, we can actually say when. So I'll put a condition. I'll say where are my controls here, and I'll put a condition. I will say if, and let's go to sensing. So if my right click is pressed, that is right arrow, then point towards 105. Similarly, what I could do is I can actually duplicate this block, move it here, and then I can say if I am moving towards left, if I have clicked on the left arrow, then move it slightly up like this. Let's see how this works out now. But when it starts, let's do that. When it starts, we want it to point in the right direction only. So that's in motion, and because otherwise it will start from this position. So let's say where is the point in direction? Yeah. So when it starts, yeah, point in this direction. So let's give it a try. Let's start this, and the cat is moving. Oh, it's actually moving too fast. So let's put a bit of a delay, or maybe we can say only one step. Let's see whether this is okay. Let's move it behind a bit. And yes, so if I am pressing right, but what's happening? It's not detecting. And the reason it's not detecting is because this particular detection is happening only once. That is, while this was clicked, it is not happening forever. So let's go back and let's put the forever block over everything. So this whole thing keeps happening repeatedly. Again, let me move this behind and let's start. So if you see, as I am pressing, it goes up or down. Is that right? So there, it's going downwards. If I press it, it just keeps going upwards. Now the thing is, it was pointing in that particular direction. So that was essentially the issue. It was not continuously happening. The direction is fixed. And obviously we can use various operators or structures to actually change this structure. But we also, let's say if you want it to bounce, can we do that? And actually yes. So we can obviously say something like this. Let's give it a try. There you go. It just bounced itself. So essentially this is the best part about doing it. You can actually, the kids or students can actually use the blocks which are available on the left side as much as possible, and learn the programming. They do not need to refer to a book. They just need to look towards what is there on the left, try and combine the different blocks together and make sense of how to explain certain tasks to computer logically. That's the very basic structure of what a scratch is. And I could actually ignore this entire part and let me say delete, say delete everything. And what I would do is I'll say point towards mouse cursor. Right, this is going to happen forever. Let's give it a try. What is trying to do? So now my cat is going to chase the mouse pointer. There you go. And lot of interesting things can be done just by using this simple idea. What other sensors exist? Like we don't need to actually refer to any big book or anything like this. We just need the references which are here. We can just take things like this and we can ask ourselves, what this mean over here. Like for example, let's say touching a mouse pointer, touching an edge. That's the simplest thing we can do. We can check for distances. Um, and then there are obviously additional stuffs that we can go over here. We can have some instruments to play while doing things. We can have a pen to draw that. So in order to draw those shapes, I had to use a pen operator. Uh, then there are some things to deal with various embedded components out over here. This is quite interesting. There is a text to speech project also. Let's try and include yep, there you go. So this is the video got interact. So I get a video interaction over here, and I get certain sensors also, as you can see. So if you see, let me drag this, and what I see over here is when so it is trying to actually see the motion of on a given sprite, so a sprite or a stage. Let me go to sensors, and what do I have over here? So no, nothing over here. I think it is completely to deal with the video sensors. And my video motion, oh, this is to do with the sprite. So when the video motion on the sprite is greater than that number, then maybe something is going to happen. So let's try and do this, but let's also do something interesting. Let's say over here, when the video motion, so this is all related to the sprite, by the way, this is not stage. So if you see, the code blocks are different for each sprite and global for a stage. So stage is the whole environment that you see, and sprite is every object that you have over here, every individual one. So since this is a sensor, what I am trying to say over here is when the video motion on that particular object is greater than 10, then let's make a sound, right? Then play sound here, or no, let's say play sound meow till done. So, so there you go. I just need to tune this to maybe something like 5, and maybe I'll have something else. Maybe, there you go. So I can actually poke the cat now. So this is you can actually make, oh sorry, you can actually make bubble busters using this. Very interesting games can happen through this, and if you have probably done this in a right way, maybe you can even try and control the robots through this. So that's very basic of this. So before we conclude that this is just something to do with games and nothing to do advanced. I actually showed some advanced examples there, but I have also used this to teach the very common algorithms that are generally used in programming, like bubble sort, for example, could actually be taught in a very interesting way using Scratch. And once you're taught it that way, then nobody has to by heart those algorithms anymore, because they just know the flow in which they can go about creating it over here. So that's the best part about it. I'm not sure whether we have time to look at that example, but maybe if the time permits, we can actually try how that algorithm evolves through simple blocks. Uh, for now, that's what the Scratch is. Any questions around it?
Just for curiosity's sake, you can show some AI blocks which are there in the extensions if you want to, face detection or something like that.
Yes, so I haven't tried AI blocks myself, but maybe let's try doing something, because this is just evaluation, right? So let's
just
try.
to give the scope to the audience that that level is possible. So it's not being dealt just as a kiddish thing.
Yes,
Which it is
right.
not. So just I want to show them that it is not just. basic stuff.
So I think
Hello.
there you go. So this is part of
Hello.
that stuff. What we were talking about, but there are other things over here. Translate text into many languages. That's something which is directly possible. So I think the AI related stuff is directly not available here with the default version of Scratch. For that, you need to actually go to something which people have built using Scratch, like PictoBlocks or something. That's slightly
Yes.
advanced
Correct.
things.
Yeah. So only what is there here, I think, is just the video sensing part, which senses your
The
hand,
video
like
sensing
hand
part,
tracking.
exactly. So
Yes.
now I've removed that block, so this is not going to work anymore.
Yeah. I guess we are open to questions. I guess so. There are two new people who are completely unaware about. So Vipin and Devendra are not were not aware about Scratch at all. So I think
Hi.
they get the priority to ask questions.
Yeah, yeah. Hi. I was trying to find the pen. I didn't. Yeah, can you show me where that pen is?
Yes, good,
No,
interesting.
in YouTube, I saw there is an option for pen here, but in this version, I
So
not
it's an
find.
extension. It's an extension. So you need to go to choose extension. So okay, let me show it. If you go here, do you see that lower left?
Yeah, yeah.
So it says add extension. You need to go there and you need to select pen, and then you
Oh,
get all the pen options out there.
thank you, thank you. Yeah, I was trying some example of this. So only that I did not find. Yeah, thank you.
So in the old version, I think in the old version the pen was available by default. So
Yeah,
yeah,
yeah, by default. Yes.
in the
Thank you.
recent thing, what they did was they tried to introduce a lot more concept, and it was getting very cluttered over there. So they tried to separate things out.
Okay. Okay. Yeah. Thank you.
Thank you.
Nicely thought. This is my second workshop, I guess. Last time I had attended one embedded system workshop, which you have
Okay.
conducted for NITTR. I was there, if you remember.
Yeah, I think that was yeah,
Long back.
long back, maybe
It,
more than 5 years ago.
and it was very interesting that time.
Thank you. Thank you.
Yeah.
Any other questions?
I would like to try many things. Okay, if I get stuck, I might contact you.
Sure. Sure.
First, I will try first, because this was something new for us. Okay. So
Right.
I tried to. Yes. Okay. If I have any doubts, I will try to contact you. Yes.
Definitely. No problem.
Yeah. Thank you.
So actually, initially I had an idea of a 10-year-old kid taking this class, but then I decided against it. Otherwise, I wanted to take this class just for the sake that it is possible. Age doesn't matter. So it's as simple as that. Somehow it happened. Yeah. Maybe
Absolutely.
next
Like
time we'll have this session.
age doesn't matter, and there are many examples out over here, and some of the advanced concepts are actually even created by kids because you just grow over it. It's nothing like you have to buy hard things. You just grow those ideas while playing around with different concepts. Eventually it gets into your head, but at all point you get to see something happening. There is nothing like let's say if I'm trying to write a Java program, I have to remember some syntax here and there. There is those complexities don't exist. But at the same time, it actually encapsulates all the principles of object oriented message passing and everything, which even C++ doesn't have to demonstrate. So that's the best part about it.
Hi, if you have some good links for this, can you send us? And,
I can't hear properly.
yeah, if you have some good links on this particular topic, can you send us some good
Yeah, sure, sure.
links? Yeah.
That would be for a good reference.
Thank you.
So actually, during this pandemic, what has happened is there are so you all know right Whitehead and all this the big thing which has happened, the big controversy about Whitehead and all that, and especially all the urban kids joining these online coding sessions. It's become a big boom now. So if you take it the other way, you might say that Whitehead is like but what has happened is because of it, a lot of marketing has happened, and many kids in the urban areas with access to laptops have joined online coding. So if I'm not mistaken, in my network, at least 20, 30 kids have joined the online sessions on Scratch. and they have graduated from online scratch to app building and much more stuff. So like 2 months courses, 3 months courses. They have paid anywhere between 10 to 15,000 3 months course. So it's a big money which is happening right now in urban areas, and it's not that it's a money making business, but kids are learning a lot, and if that could be given to our village kids, it will be like a great thing. It will be a great thing. Yeah.
Definitely, definitely, and probably the best part is just by practicing it on this system, they actually get to learn those algorithms without having to by heart it. But most importantly, hello.
Yeah, we can hear you.
Yeah. Okay. So most importantly, it is not actually about learning programming. It's also about getting used to the idea of logic, that something big and complex can be actually achieved by solving little and smaller problems together. So I just like how do we move a cat around here? So it's each of these are individual simple operations. Move in a particular direction, rotate yourself in a particular angle. For example, say meow. All of that, and when you combine them in a specific order with a specific logic, it forms something more complicated. And just by doing that, you actually end up building Super Mario or maybe bubble sort or some other data structure algorithms or something like that.
By actually avoiding the complexity of writing texts of code. So you have avoided the whole syntax of the language that you have to learn. You don't need to learn a language now. You just have to follow logic to do
Exactly.
whatever you want to do.
Exactly. And other problem which generally happens is when something like Java is used to teach, people read from top to down. And that's often not how programming is to be understood. So if you see, while we are writing this, we actually started with move one step. And then we actually pulled forever over it. And then we said, point in that direction. Then we introduced when flag is clicked, for example. So we went step by step over it. So the step is actually to start from inside out. Same thing with if you are trying out certain sort algorithms, for example, the core step is doing the swap, then doing the swap conditionally, and so on. The problem happens because people read from top to down. It also tells them how to read. So if they are reading somebody else's problem, they are trying to solve certain problem, they then eventually get into the mindset of trying to find out the simplest block first and then growing from there instead of having to look at some big code and getting scared about it.
Great. Any teachers would like to ask anything? Because teachers anyways are experts in this. If they still have something to ask, or else okay. If there is nothing, then I think we could end the session. I guess.
Yes.
Okay, great. So I think as far as the curriculum is concerned, we are supposed to share the template so that everybody can start adding on their concepts.
Yes.
As far as the sixth standard framework is concerned.
Yeah,
So I
that
guess
is
by
right.
tonight we'll be able to share the spreadsheet and we can start working from tomorrow.
Yeah, sure.
And I think we already have that curriculum which you had prepared, and I spoke to Venkatesh also. He also has the curriculum that he had prepared.
Right.
So we can merge those things with the concepts, and I think we can freeze it immediately by tomorrow.
Definitely.
Great.
Cool.
Okay, and thanks to all of you all for joining this short session on Scratch. I thank once again all of you, and special thanks to Anay for being this board for conducting this session. And let's call it tonight. Yeah, good night.
Thanks everyone. Have a good weekend ahead. Good night.
Yeah, thank you.
Yeah.
Thank you.